My name is Isaac, and together with my partner Abbas, we've created this short video just quickly demoing our implementation of a DED RAG chatbot. So this video will just quickly cover the problem that we were given, our implementation and design, as well as a quick live demonstration of our current implementation and future implementations that we would like to do if given the opportunity.
One thing we've noticed with big companies is that a vast amount of time is spent looking for the right information amongst a numerous amount of files and documents, whether it be for troubleshooting or for implementing new features. One thing we've noticed with big companies is that a significant amount of time is spent looking for the right information amongst a numerous amount of files or documents, whether it be for troubleshooting or for implementing new features. For this reason, Zitray reached out to us about a similar situation, where the issues arising were about the ability to use and learn complex systems without needing to depend on experienced colleagues.
So to combat this issue, we decided to create an AI chatbot that utilizes retrieval augmented generation that summarizes key information from uploaded files to help users with their problems. Also, to increase accuracy of our chatbot's responses, we decided to create separate databases for every system. So now we're just going to do a quick live demonstration of our current implementation. Okay, so as we see here, using the live demo, we currently have just a basic front-end display with the ability to ask the model questions, create new databases, and also upload files. Moving over to the top left here, we are able to filter through different databases. Now, the reason why we have multiple databases is mainly due to the complexity of the machines that are currently at CSIRO. We know that many of the systems currently there do implement many subsystems and submachines integrated quite seamlessly in order to create and to manufacture complex things. So because of that, we needed to separate the information that the AI model has access to in order to increase accuracy, in order to increase accuracy of its response. So as we can see here, we can filter through and we can also create our new database quite easily. So if a new machine does come into CSIRO, it is able to create its own database with its own relevant files. So if we can see here, we can just do a simple leg. And as we can see here, we can filter through. And if we so choose so, also delete the database. Now, moving over to file uploading, the type of files that we were given were mainly just instruction manuals and instruction files. So if we see here, many of the PDFs basically just explain what the type of model or what the type of components are, how they work, and what they're made up out of. So if you can see here, we can just drag and drop a PDF, click a button, and it will upload that PDF to the database. Now, what currently is happening in the backend is the AI model is using semantic chunking to filter through the PDF, collect certain chunks that it deems has the same round relevance or the same topic, and creates a vector and stores that in a vector database. Now, also another feature that we were able to implement is the ability to create new documents and add them into the database. So if a user or a technician discovers something new or figures out a solution to a certain problem, they're able to create their own file that will directly be implemented within the chatbot, which then the chatbot can use as reference material for future problems. Now, if we go over here quickly and ask it a simple question, the chatbot will now filter through the vector database and collect chunks of information that it deems as relevant to the certain query that we've asked. Now, the problem that we're facing at the moment is one, due to the amount of data that we've been given, as well as the type of data that we've been given. Due to the way retrieval augmentation generation works, our model's response is directly correlated to the quality and the amount of data we're given. So if we want more accurate and more easily to digest responses, we need better data. But as we can see here, we were able to get a response, and we were also able to implement a reference system whereby the model tells us exactly where as to what information is being used in its response. So it's able to tell us the type of PDF and also the page number. So as we can see here, this is the PDF that we've been referencing, and which is MH215, which as we can see here is one of the uploaded PDFs in our database, as well as the type of page. And that is currently all the stuff that we've been able to implement it in the amount of time that we've been given.
As you can see, we are still in the development stage of this prototype, and if given the opportunity, we would love to bring more ideas to fruition.